Hi guys, now let's solve some PYQs on the ER model. So let's take a look at the first PYQ, which is from GATE CSE 2024. So let the specification be: instructor teaches courses, student register for courses, courses are allocated classrooms, and instructor guides students. Okay, so which of the following diagrams correctly represent the above specification? Okay, so they have given you 4 diagrams, and now you have to tell which one of this correctly represents the specification that has been given. Okay, so let's see this. So the instructor teaches course. Okay, then student registers for the course. So let's start looking at one of each one of them and see if they fit the description that has been given to us. So instructor teaches the course, right? So this is correct. So this is correct relationship. The instructor is teaching the course. So this is correct. Student registers for the course. So now this registration that they have given, right? They have given it as a as an entity, right? But it should be a relationship between the course and the student entity, right? So also student should be an entity over here, right? So here this is the flaw, right? So this is not correct. Student should not be a relationship. It should be a entity, right? So this is incorrect. So this option is incorrect. Now let's look at the second option. So instructor teaches course. So this is correct. Now we have project registers on course, right? So this is the relationship that they've given. Project is an entity, registration and course, right? But student registers for the course, right? So here there is no mention of the student entity at all, right? So this is also incorrect, right? So this relationship is incorrect because it should have been a relationship between course and the students, right? So students should register for some course. Okay, so this is incorrect. Again, instructors guide the students. So this relationship is also incorrect because instructors are not guiding projects. Instructors are guiding students. So these three things are incorrect. So this is also incorrect. Now let's look at the third option. So we have instructor teaches course. This is fine. We have student registers for course. This is also fine. Instructor guides students. This is also fine. Now we have classroom, course and allocation, right? Now this is incorrect, right? This is incorrect because so classroom is allocated course. So this should have been like this, right? Classroom and course would have the relationship allocation, which is not there. So this is also incorrect, right? So this should be the one which is correct, but let's see. We'll verify whether this is correct or not. Then we'll take it. So we have instructor teaches course, which is fine. Student registers for the course, which is also fine. Instructor guides the student. Awesome. And then we have classroom allocation and students. So course and classroom are related with the relationship allocation. So this is also correct. So the answer is fourth one, which is the D option. So the answer is D. Fine. Okay. Now let's look at the next one from the GATE CSE 2024. So in the context of owner and weak entity sets in the ER data model, which of the following statements is true? Okay, so they have given you 4 statements and they're asking you which of the following is true. Okay, so let's see each one of them one by one. So the weak entity set must have total participation in the identifying relationship. Okay, so this we know is right? So the weak entity set must have a total participation always, right? Because that weak entity is dependent on the identifying entity or the owner entity for its identification. So hence this is correct, right? So this A statement is correct. Now they have asked us which of the following statements is true, but we should check the other one also. So this is MCQ, but let's check why the other options are incorrect. So the owner entity must have total participation in the identifying relationship. So this is not correct, right? Owner entity need not participate completely in the identifying relationship. For example, if you have a relationship between employee and dependent, depends on, or say there is a dependent relationship, employee has dependents, right? So one of the, so this is the owner entity here, this is the weak entity here, right? So here what you have is this relationship has, and these are 2 entities over here. So an employee cannot have some dependents, right? So it might happen that some of the employee does not have any dependents. For example, so there could be reasons why the employee does not have dependents. So if that happens, then employee need not participate in this relationship, any employee, right? So this B option is incorrect. So both weak and owner entities must have total participation in the identifying relationship. This is incorrect, right? Because we know that owner entity need not participate totally in the identifying relationship. And neither weak nor owner entity must have total participation. This is also incorrect because we know that weak entity should have a total participation in the identifying relationship. Fine. So the answer is A. Okay. Fine. Now let's look at the next question, which is from GATE CST 2012. Given the basic ER and relational models, which of the following is incorrect? Again, this is an MCQ question, but we will check every option. Okay. So we have to use knowledge from ER model and the relational models. So an attribute of an entity can have more than one value, right? So an attribute of an entity can have more than one value. So this is correct, right? So an entity can have more than one value, right? So we know that, say, student is there, right? So this student can have a multi-valued attribute. So this is allowed in the ER model. So it can have, say, phone number, which is multi-valued, right? So this is allowed. An attribute of an entity can be composite. This is also fine. We have seen this in the ER model. So this is related to ER model. This is also related to ER model. In a row of a relation table, now they are talking about the relational model. So they are saying in a row of a relation table, an attribute can have more than one value. So this we know is false, right? So in relational data model, we cannot have multiple values in a single attribute, right? So we can't have multi-valued attributes in the relation model. So that's why this option is incorrect. Let's take a look at the option. In a row of relation table, an attribute can have exactly one value or a null value. So this is correct, right? So based on the domain, we can either have exactly one value or the null value. So this is correct. So the only option which is incorrect is C option. Fine. So the answer is C. Okay. Now let's take a look at the last PYQ. So GATE CST 2008. They are asking us, consider the following ER diagram. They have given you a very nice ER diagram. You have to find the minimum number of tables that are needed to represent M, N, P, R1, R2. Okay. So you have M, P and N. There are three entities. You have two relations. Okay. So let's see. So this is a strong entity. Okay. So this is a strong entity. So we are definitely going to have one relation for this. So this, let's say, I'll say one relation for. So we'll definitely have one relation for M, right? M will have relation, right? Now this M relation does not have any multi-valued attributes or any multi-valued attributes. So we need not break it down. So M will have one relation. Okay. Now let's take a look at this P entity. Okay. So P is also a strong entity because it has a primary key, right? So this P entity will also have one relation. Fine. So this is relation 2. Now let's take a look at N entity. So N entity is a weak entity. How do we know it's a weak entity? Because it's in a double square. Also it's connected to a double rhombus or a diamond, right? So this is a weak relationship, or this is called identifying relationship. Identifying relationship. Right? So this is an identifying relationship, and we have seen how we convert this to a relation model. What we'll do is we'll have the table for this P entity, we'll have the table for this N entity, and we'll add the primary key of this P entity into this weak entity and as a foreign key, and that will help us in identifying the relationship, right? We'll have a composite key of N1. N1 is basically the partial key of this weak entity N. So we have to create one table for this as well. So we'll create one table for this as well. So we have relation 3, right? So this R2 relation, it does not need a table. Does not need explicit table, right? Another thing that you should ensure is that the weak entity should be in total participation. It is, right? So this is correct. Now the only thing that we have to worry about is R1, right? So R2 doesn't need an explicit table. So does R1 needs an explicit table? So let's try to understand this. So this is in total participation, right? So this is in total participation and this is in partial participation. So this is the many side, right? So this is N, right? And this is 1. So this is many to one relationship, right? So now for the many to one relationship, if you are going to convert this, we'll put the primary key, the foreign key in the many side, right? So what we can do is, if you have this M table, we'll have M where we'll have M1, M2, M3, right? M3. So here we have this P table, right, which has P1, P2. So we'll make this P1 here. We'll get this P1 here on the many side. Anyways, this is in total participation, so we will get this, and this will reference this particular primary key, right? So this is the primary key and this is the foreign key. So this will reference this, right? So we can do this. We have seen this in many to, so this is many to one relationship. So we always put the primary key on, the foreign key on the many side. So we'll put it here. So this relationship R1 also doesn't need an explicit relation, right? And they're asking us about the minimum, right? So there can be null values in this, so we don't care. Anyways, this is in total participation, so there will be no null values over here. So this R1 doesn't need explicit table. Okay, so how many tables do we need? We need 3 tables, one for M, one for P, and one for N, and obviously we'll add some foreign key constraints to represent R1 and R2. So the answer is B. Okay, so the answer for this particular question is B.